Suppose if a fails occur, if the test fails, alright, so the fault will be within one of the nodes, one edge away. So whatever the node that you have, so I will call this as a neighborhood. What is that it is combining? So it is combining both structural and behavioral type of testing. Graph is a combination of nodes and edges. Hello everyone, I welcome all of you to the yet another interesting session on integration testing. So guys, what is that I have in this session? In the last session, I have discussed some of the important topics like bottom-up approach, top-down approach, and also I have discussed sandwich integration. So now, what is that I have in this session for all of you guys? So guys, let's check out. So what is that you have? The first topic that I will be discussing with all of you is call graph-based integration. So what is the next topic that I will be discussing? So guys, inside this call graph integration testing, I have got two topics. So that is pairwise integration. Another one is neighborhood integration. So I will be discussing these two. This is going to be very, very interesting and important as well. Along with that, I will also discuss the pros and cons of these topics. After that, I will be discussing one of the major important topic in this chapter, that is MMPath. So please remember this. This is going to be very, very important when I'm discussing this. So please don't skip this part. After that, so they have given a case study. I will show you how you will implement all these topics, whatever you have studied in this chapter. So without wasting much of your time, let me get into the concept. So guys, in the last topic, in the last session, in fact, we have discussed what exactly functional decomposition. So functional decomposition in the sense, say for example, I have the main program, I will start splitting until you get the individual units. So now I have the functional decomposition concepts with respect to the waterfall model, but when I'm using this, I have some of the drawbacks. So what is the major drawback that I have? So please remember, it gives me impossible test pairs. When I'm using the functional decomposition, it gives me the impossible test pairs. So to solve this problem, so I am going to the next concept, that is going to be call graph-based integration. So call graph-based integration will help me to solve this problem. Yes. Let's check how exactly it is. When I was discussing the previous topic, so please remember the three strategies, that is top-down, bottom-up, and the sandwich. So guys, it was using the concepts called stubs and drivers. But how exactly I'm going to replace that stubs and drivers with the next concept, that is going to be two important concepts that you need to remember. So that is nothing but, so please remember, it's going to be pairwise integration and neighborhood integration. So this is the two important topic that you need to remember with respect to the call graph-based integration. When I'm performing the call graph-based integration, I will have two different types of integration. So that is going to be, so please remember, the first one that I have is pairwise integration, and the second one that I have is neighborhood integration. So what exactly is this? So let's check. Guys, before I start my pairwise integration, so I would like to show you the chart which I'm going to discuss. So please observe. So this is the example that I've taken, the calendar example, which I was discussing the functional decomposition in my previous session. So what exactly functional decomposition is all about? Yes, I have the main program and I'm splitting that into subsystems until I have the individual units. So this is what I will call it as a functional decomposition. Now, let me get into the example, or let me get into the explanation of pairwise integration. So before that, I want all of you to get familiar with the example when I'm speaking. All right, so let me get into that. Pairwise integration. What exactly pairwise integration is all about? So listen to me carefully. So the idea behind the pairwise integration is to eliminate the stubs and the driver development effort. So in the last session, we have stressed on this point. When I was discussing the pros and cons, I have highlighted that. So it is taking a huge effort to build the stubs and the drivers. Then how do I eliminate this? So the only way that I have is with the concept of pairwise integration. Let's check how. The main advantage of pairwise integration is high degree of fault isolation. I can isolate the faults very quickly. So please listen to me how. If the test fails, the fault must be within one of the pairs. Say for example, I have two nodes. Okay. This is what I will call it as a pair. Suppose if a fails occur, if the test fails, all right, so the fault will be within one of the nodes. That is what you need to understand. So guys, this is an advantage that I have. So guys, with respect to the pairwise integration. So please observe the major drawback of this pairwise integration is, so please observe the biggest drawback is that for the units involved several pairs, several pairs, a fix that work with one pair will not work with another pair. What exactly it means? The solution will not work for one pair which is working, and for another pair it might not work. So that is going to be one of the drawback with the pairwise integration. I repeat, I have several pairs in my unit, but you will give a solution for one pair which is having a problem, but the same solution might not work for other pairs. This is going to be one of the biggest drawback that we have. All right, moving forward to the next point that I have. The call graph integration is slightly better than the decomposition tree-based approach. Remember that. So call graph is better than the previous methodology, what we were using, that is decomposition of a tree. So please remember along with that, but both can be removed from the reality of coding being tested. So it is not helping me for the coding being tested. So that's a major drawback again here also. Keep that in mind moving forward. So please understand, sir, pairwise integration. How? So what do you call it as a pair? So please observe, this is one pair. I'm calling this is one pair. All right. So, and also I have, this is also, I will call it as a one pair. And this is two nodes. That's what I will call it as a pair. Suppose if a fail occurs in the test, so I can easily identify the fail will be in any one of the nodes. So that is a major advantage that I have with respect to the pairwise integration. So the one more advantage that you need to remember is, so guys, here you are not using any stubs and any drivers. That's the major advantage that you need to remember. And one more important point that you need to remember is, say for example, I have huge number of pairs. The problem will occur here and I'll give you the solution. So this solution might not occur for any other pairs, whatever I have. That's one of the drawback that you need to remember at this point of time with respect to the pairwise integration. The next one that I have is all about the neighborhood integration. What exactly neighborhood is all about? So guys, remember this definition for the neighborhood. So what is that? The neighborhood of a node is a graph, is the set of nodes that are one edge away from the given node. What is the meaning of it? Guys, this is my node. So the one edge away, this is the edge, I will call it as an edge. One edge away. So whatever the node that you have, so I will call this as a neighborhood. For this, this is a neighborhood. For this is a neighborhood. For this is a neighborhood. For this is a neighborhood. One edge away nodes, I will call it as a neighborhood. That's what you need to remember. So guys, hope you understood what exactly neighborhood is all about. All right. So for this is a neighborhood. For this is a neighborhood. All right. So whatever you're able to see in the grayish color, so that is depicting the neighborhood. So integration. That's what you need to remember here. So fine, let's understand. So why do I need? Again, as I told you, guys, pairwise and the neighborhood integration will avoid or will help me to reduce the usage of stubs and the drivers. That's a major point that you need to remember. So what is that? Moving forward, so this neighborhood integration will help me. So when it will help me when I'm building the sequence. So I have the series of builds. Okay, do you all remember spiral model and evolution model? So do you all remember that? So it gives you the series of builds, series of prototypes at that particular point of time. So this is very, very useful. This is very useful is what you need to remember at this point of time. So moving forward. So guys, and also the drawbacks, the pros and cons of pairwise integration. So please remember, suffers from fault isolation problem. So even this also has got the fault isolation problem is what you need to remember. Along with that, so you will also have the redundancy problem. You'll also have the redundancy problem, repetition. Redundancy in the sense what? Repetition. What exactly the repetition is all about? Listen to me carefully. Nodes can appear in the several neighborhood. Whatever the nodes that you have, so it can appear in the several neighborhood. So that's what you need to remember. So guys, observe here in this diagram. So for this is also a neighborhood. So even for this also, this is a neighborhood. So this might create the problem. So this is one of the drawback. So which creates the redundancy. That's what you need to remember here. All right. That's what you need to remember here. So moving forward to the next point. So please understand, assumes the correct behavior follows from the correct unit and correct interface. Not always the case. Remember this. This is one of the important point. Always you assume the correct behavior follows from correct units and correct interface. Not always everything will be correct. That's the most important point that you need to remember at this point of time. So moving forward to the next point. So guys, motivation. So why do I have motivation for path-based integration? Sir, this is one of the important next topic that you need to remember with respect to the path-based integration. So why should I have the path-based integration? Let's understand this. So combine, it's a very important point. What is that it is combining? So it is combining both structural and behavioral type of testing. Remember, this is one of the important point that we need to understand. So when it comes to the path-based integration, so I was discussing, what is the first point that I started with? I was discussing the pairwise integration and the neighborhood integration. But the next concept that I'm going to discuss is path-based integration. When it comes to the path-based integration, so it is very important that I need to remember here. So it gives me the testing for both structural and behavioral. So that's one of the important and advantage that I have with respect to this type of integration. The next point that I have is, please remember the basic idea with respect to the path-based integration. Guys, the main idea behind this is, it focuses on interaction among the system units. What is that? It focuses on the interaction between the system units. So rather than testing the units which is built separately. So that is what you need to remember here. That is a major thing that we need to understand with respect to the path-based integration. So moving forward, and also it's very important point that you need to remember. What is that? Interface-based testing is structural, while interaction-based testing is behavioral. So you need to remember these 2 points. What is that? Interface-based testing. So if I am testing the interface, it is structural. You will get the information about the structural. So, but when it comes to the interaction, so when it comes to the interaction-based testing, you will understand the behavior, how exactly the units are working. So that is what you need to remember here. So this is all about the thing that you need to remember with respect to the path-based integration. Let's understand more about some of the concepts which I've used when I was explaining the previous concepts. I was using a concept, I was using a word called source node. What exactly the source node is all about? Guys, let me make it very simple for you all to understand. Source node in the sense, the main program or the main root node. This is what I will call it as a source node. This is what I will call it as a source node. Let me keep it very simple. The last units, whatever you have, individual units, this is what I will call it as a sink. So this is what I will call it as a source node, and this is what I will call it as a sink. That's what you need to remember at this point of time. So you understood what is source and you understood what is sink. Okay, that's what they have explained here. The next concept that I have is MEP. MEP in the sense module execution path. What exactly module execution path? So inside my module, I have a sequence of statements. So that's what you need to remember. Listen to me carefully. Sequence of statements within the module. All right. So sequence of statements, what I have inside the module is what I will call it as a MEP. So please remember. So it begins with the source node. Source node in the sense the root node. So it begins with the root node and ends with a sink node, whatever the units that I have. So it ends here. So this is what I will call it as a MEP, the execution module execution path. All right. So hope you understood what exactly MEP is all about. Moving forward to the next one, that is MMPath. When it comes to the MMPath, a module to module path. A module to module path is what I will be calling here as a MMPath. This is going to be very, very interesting and important topic, in fact, with respect to the exam point of view. All right. So guys, listen to me carefully what exactly MMPath is all about. So guys, an interlinked sequence of module execution path and messages. So this is what you need to remember it as a MMPath. So yes, what exactly this MMPath? Where do I use this MMPath? Listen to me. So used to describe the sequence of module execution path. Why do I use this MMPath? It is used to describe the sequence of modules execution path. Sequence in the sense one after the other. Execution path. So how exactly it is executing one after the other between the modules. That's what you will be able to understand with respect to the MMPath. So fine. So and also how exactly it includes the transfer of controls among the separate unit. So that's what you need to remember. How exactly it is executing one by one and how exactly the transfer is controlling from one part to another part. Say for example, I have the program. It is not mandatory that, so imagine I have a program and I have 100 lines of program. Okay. So this is one function, this is one function, and this is one function. You can also call the function inside the function. So that's what you need to remember. Say for example, I might call this function first. And then after that, I might call this function. So and after that, I might call this function. Inside this function, I might call this function. So how exactly the function is being called, how exactly the sequence of execution is happening. So that you will get to know in detail with the help of MMPath. Sir, we are not understanding what you are saying. Yes, for this, I have a diagram. Let me explain this concept with the diagram. All right. So next one, before that. So guys, MMPath always represents a feasible execution path. What is the feasible execution path that I have? So that will be represented with the help of MMPath. So that is what you need to remember. Yes, let's understand that previous concept with the help of this diagram. Imagine this is what the beautiful diagram which speaks about the MMPath across 3 units. I'm using 3 units. This is a unit number 1, unit number 2, and unit number 3. I'm representing the unit 1 as A series and unit 2 as B series, unit 3 as C series. What exactly units are you calling about, sir? The functions is what I will be calling it as a units is what you need to remember. All right. So fine. A1, A2, A3, A4, A5, A6, A7, A8. What exactly is this? This is the statements. This is the lines that I have in the function. So this is how the execution inside the function will happen. You can also treat it as units or I will call it as a function. That's what you need to remember. So fine, this is how the execution is happening. So now listen to me carefully. I'm executing this. So this line will call this function. So I will call some function. So the control, the message will go to this. So it will start executing from here. So once it is coming to this line, so to complete the execution of this line, again the call will come to here. So it has to complete the execution of all this line. So then after that, so once it comes here, again it will come back, the return message will come back here. That's what you need to understand. So fine. After that, what happens here, sir? The line, it will start executing this. So once it reaches here, so it will finally returns the result to the A6. So after that, so it will come to the A7 and A8. So this is how the execution is happening. I will be explaining this with the program. Okay, I will take a program. So you all know that we have a famous program that we have already discussed, the next date problem. Okay, I will take that program and I will explain how exactly the message passing and the message written is happening. But remember, so you need to understand the flow of execution between the units, and also you will be able to understand the feasible path. So with the help of MMPath. That's the most important advantage that you have with respect to the MMPath. All right. So moving forward to the next points that I have with respect to the MMPath. So a given set of units, their MMPath graph is directed graph. So it's a directed graph. The first of all, whenever I speak about the MMPath, it's a directed graph. Directed graph in the sense what, sir? Whenever I'm using the graph is a combination of nodes and edges. Sir, what is nodes? So this is what I will call it as a node, and this arrow marks whatever you are using. So this is what I will call it as the edges. Whenever you have the directed edge, observe here, this is the direction. From here, the execution is going down, right? So this is what I will call it as a direction. So this is what I will call it as a directed graph. So suppose if you have the graph like this, all right, so if you have the graph like this, so this is not directed. So I don't know whether from this node it is going to this node, or from this node it is going to this node. I don't know the direction. So, but when it comes to this is a directed graph. That's what you need to remember here. Okay, that's our first point. And nodes are the module execution path. What is the nodes? Nodes are the module execution path. But when it comes to the edges corresponds to the message and returns from the one unit to another unit. So edges will help me to exchange the message from one unit to another unit. But nodes are what? Nodes are the execution path. That's what you need to remember. Moving forward, the definition is with respect to the set of units. It is directly supported. So please listen, this is very important. It directly supports the composition of units and the composition based integration. When it comes to the MMPath, it directly supports the composition based integration. That's one of the important points that you need to remember. What type of integration? Composition based integration when it comes to the MMPath. It supports composition based integration. That's a major thing that you need to remember in this slide. Now let's understand how do we calculate the MMPath complexity. In the previous slide, we have seen the formula, right? So what is the formula? So V of G is equal to, so please remember, E minus N plus 2. So guys, what is that I have? So what is the meaning of E? What is the meaning of N? So E in the sense edges, N in the sense nodes. So please check. So let's consider this diagram. So what is that I have first? Edges. How many edges I have? So this is the first edge, second one, and third one, and the fourth one. So totally I have 4 edges. So guys, E is equal to 4 minus N in the sense node 1, 2, 3. So 3 nodes I have plus 2. So 4 minus 3 is going to be 1 plus 2. So V of G is equal to, so 3. So that's what they have given here. So please observe. In the same way, I have one more MMPath diagram. So please observe how they got V of G is equal to 4. So let's check that. Let me erase everything. So what is the formula? So please listen, V of G is equal to, my dear students, E minus N plus 2. Guys, what is E? Edges. How many edges you have? So 1, 2, 3, 4, 5, 6. So you have 6 edges in total. So 6 minus, how many nodes you have? You have 4 nodes. 1, 2, 3, and 4. So 4. Let me write like this. 6 minus 4 is going to be 2 plus 2. It's going to be 4. So V of G is equal to 4. That's how you have got 4. So guys, if you want to calculate how to calculate the source node, so I have the formula for source node also. To know that source node formula, so you have to attend my Q&A session. So that's going to be a surprise for all of you. So guys, moving forward to the concepts, that is pros and cons of MMPath. Why should I use MMPath? What is the advantage of MMPath and what is the disadvantage of MMPath? So let me discuss that one by one. Benefits of hybrid functional and structural testing. So that's a most important thing that I have. It's a benefits of both functional and structural testing. What exactly functional means, what exactly the structure means. So please understand, functional in the sense it represents action within the input and output. Functional in the sense what exactly is happening, what is that you are doing with the input and output, how exactly you are processing. So that is going to be described with the help of functional. But when it comes to the structural, so please understand how they are identified. So that is what you need to treat or you need to remember with respect to the structural. So this is the two important points that you need to remember, all right, with respect to the MMPath. All right, moving forward to the next one, it avoids pitfalls of structural testing. It avoids the pitfalls of structural testing. That's going to be one of the points that you need to again remember. Moving forward, unimplemented behaviors cannot be tested. Suppose if you have not implemented, so you have not implemented any feature, then you cannot test it. So unless and until you implement it, only then we can test it. That's going to be one of the drawbacks that I have here. So moving forward to the next point. So guys, path-based integration is closely coupled with actual system behavior. So that's most important. When I'm using the path-based integration testing, so guys, it is closely associated with the system behavior, how exactly the system is working. So that's what you need to understand with respect to the advantage of MMPath. So next point that you have is it works well with the object-oriented testing, and also no need for stubs and drivers development. That was the problem that I had earlier, but now I don't have to have the stubs and the drivers with respect to the MMPath. But when it comes to the decomposition, obviously I need the stubs and drivers, but when I'm using the MMPath, I don't need this stubs and drivers is what you need to remember. So the last point, there is a significant effort involved in identifying the MMPath. So you need, a little effort is required to identify the MMPath is what you need to understand. So guys, here it comes to an end of the session. So guys, we have come to an end of this session. So guys, here it comes to an end of the session. So if you want to understand what exactly the case study that I have in this chapter, so watch my next session. So until then, take care. Bye-bye.